So someone asked why we used double pointers instead of in certain function, and in other function we used single pointers. So we're going to look at that. Why? The first thing is we have to understand how um, pointers works. Let's say you declare a variable called a, and you want to change the value of this variable. I'm going to include the standard input output library first, and print the value of a. So a is equal to that. And when you want, there is two ways you want to you can change the value. First, you have to notice that this is a local variable, so a local variable for the main function, and you can use the name of the variable and change its value. Let's compile this code and see. So we have 5, 1, 2. Oh, this is the old one. GCC main.c, then the O option. Uh, I'm going to delete the old files. Okay. Now let's compile the code again. There is something bizarre happening. Okay, so let's retry again. Yes. I don't quite understand. Okay, so when you compile and run this code, you will have a equal 183. So let's create a function called change value. So in order for this function to be able to change the value of a variable local to another function, like uh, the main function, it cannot, it needs to know the memory location of that variable. You can say change function will receive something like um, an integer like that. I'm going to call it something like I or K. And if you say K is equal to 182 and you compile the code, um, then you call change value on a variable, compile the code. What will happen? You see that, oh, sorry, uh, it's kind of bit, yes. And you run the program, you'll still see a is equal to 183. But we want change value to be able to modify the value of this variable. So it can't do it because when you say a, this will pass the value stored in the variable a. But change value needs to know the address of the variable a in order to directly access the memory locations, then modify things. So we want change value to know about the memory location of this variable or any variables. then knowing the address, it can do whatever it wants. So for that, we say we're going to receive addresses, and I'm going to call it like that. So now it receives an address, and any function who knows the address of a variable can try to change the value stored in that address. So we use the dereferencing operator to say, okay, we have access to the address. Now we want to change the value to something like 111. Let's compile this code. Yes, here we have to pass in the address, not the value. So now the memory location where this variable is stored is the one that's going to be passed to change value. Now change value knows about the address, and it can use that address and modify the value stored in the address to 111. Now we're going to compile and see. Yes. So change value, we change in the main function, we change the value of A to 183. Then we say, okay, we want this function also to change the value of this same variable. So it can only do it by knowing the address of this variable. So we pass in the address. Since it's know the address of the variable, it can use that address and directly change the value from the memory. So here we use the start sign. That is because this variable, its address is of type int start. What if we have a variable which is of type int start, and let's say it is a pointer, it is a pointer. So in order to be able to change the value of this variable of type pointer, we also have to add a start. And we say we pass in the address of the variable of the pointer p. So whenever you want to change the value of a variable, you take the type and you add one start. That will be give the data type of its address. So if there is any questions, you can ask. This is why here in our function shift function, we wanted to change the value of this variable. And in the append function, we also wanted to change the value of this variable. So the type of the variable is data item type start. And here we added one start to say, okay, we have data item store, then one start to say, okay, we want to store the address of a variable. Uh, the address of a variable that is a pointer to a data item type. We could have renamed this like that. So to avoid confusions, to know that this is a pointer to the first item. That also was possible, but I did not thought about it. So you can say something like that. It will also work. So that's why it's very important to name your variables with names that make sense. Now let's go back to the orders. For example, the the print items and the item count. Here, we use data item type start sign because we only needs to know the address of the first elements uh, in order to also know the value of the other elements. We could have used something like that, but if you do that, sometimes the list is empty. So a null could be passed to the print function. And if it goes something like that, that means we are required to pass in a valid data